Hello everyone, my name is Michael and welcome back to Softman's channel. In today's video, we will be treating triangles, which from my view I think it is a continuation of parallel lines. And you could see a lot of triangles in this particular diagram. And this is a past question. After going into triangle, we will take our time and solve this particular question. And then I think we will be done for the day. So now let's get into the triangles. Now, we have two major properties of triangles which will cut across all the types of triangles. Which is, of course, before we go into that properties of triangles, what are triangles? We all know triangles are enclosed plane figures, or they are closed plane figures which are bounded with three sides. So whenever you see a closed plane figure of this sort, because we've closed all ends, then and also having three sides, then we say this is a triangle. And now we have two major properties that runs through all the types of triangle. And the first property is that its interior angles, all triangles, their interior angles add up to 180. So if I have A here, B here, and C here, then we are saying that A plus B plus C equal to 180. So all triangles, their interior angles, they sum up to 180. Now let's move on to the second general property of triangles. Now we said triangles are enclosed plane figure with three sides. So you can see this line AB, line BC, and line AC. This is an enclosed, so this is a triangle. Good. And now, if I have this arrow on this particular line and this arrow on this particular line, I hope you know what it means. It means they are parallel to each other. So line AB is parallel to line CE. In our previous video, we went very deep into it. So if this is your first time, you can play or you can go through my videos and you will have a full tutorial on parallel lines. Good. So now parallel lines, he said, whenever we have a parallel line and the line touches both parallel lines, and that line becomes the transversal line. It may touch or it may even cross through. Then that line becomes a transversal line. And we said whenever a transversal line crosses through the parallel line, some particular angles are formed. Good. So we could realize that the angle formed here, which is A, will be equal to X because we have the Z shape. In our previous video, we went into this. So whenever I have the Z shape, we say they are alternate angles. So this A is equal to this X. And then the same as if I have B here and then I have my Y here, then B is also equal to Y because corresponding angles are equal. We said whenever an angle is formed under or beneath a parallel line, then it is corresponding to the other angle formed beneath the other parallel line. If it is on top of the parallel line, then it is corresponding to the one on top of the parallel line. But now we are talking about the one beneath this particular parallel line. It is corresponding to the one beneath this particular parallel line. And so A is equal to X because alternate angles are equal, and then B is equal to Y because corresponding angles are equal. So if I have 70 here and I have 30 here, then it means that X is equal to 30 and then Y is equal to 70 degrees. Good. So A plus B is equal to 30 plus 70, which is equal to 100. And then x plus y also equal to 30 plus 70, which is equal to 100. So we could realize that these two angles are equal to these two angles outside here. And whenever an angle is outside a plane figure, we say it is an exterior angle. So if we should take this particular line up this way, then we could realize that this a plus b will be equal to what? X plus y. This brings us to the general property that an exterior angle of a triangle, don't get it wrong, an exterior angle, the angle outside of a triangle, is equal to two opposite interior angles of that same triangle. So it is the one opposite to the exterior angle which are equal angle. So for instance, if we have something like this and this, we realize that we have x here. This angle, this exterior angle will be equal to the opposite interior angles, which will be what? This angle and this angle. So AB. So this one is equal to the opposite two interior angles. And these are the general properties of all triangles. Good. Now, we know what a scalene triangle, that is the first type of triangle. The first type of triangle is the scalene triangle. The scalene triangle. And it is a type of triangle with all sides not equal in length. Good. So you could realize that this one has one arc on it, this one has two arcs on it, and this one has three arcs on it. Now, the number of arcs on the lines indicates the three lines being different in the size of its length. Good. So a scalene triangle, all the three sides are not equal in length. They have different sizes in length. Good. And now, for the general property, we've already done it. The interior angle of a scalene triangle is equal to 180. Very good. Now, it has no line of symmetry because a line of symmetry is a line that divides a diagram in a way that we can fold the other half or one half exactly onto the other one. We can fold one half exactly onto the other half. Now, when you should divide this, we can't fold this exactly onto this because this will appear somewhere here. So it means it has no line of symmetry. So that is for the scalene triangle. Let's move on to isosceles triangle, being the second type of triangle. Isosceles. Good. So isosceles triangle, we say they are triangles with two of its sides equal in length. Two of its sides equal in length. So if I have A here, B here, C here, line AC is equal to line AB. Now, this is not drawn to scale, but the axis on them determine that this line is equal to this line. Good. Now, whenever we have equal line this way, they form equal base angles. Good. So these two equal lines, they form equal angles with the third line. So if I have 20 here, this side will be 20. If I have A here, this side will be what? A. And you could see it on the board. In this question, you could see this one arc here, meaning this line DE is equal to this arc here, line DC. And so we call triangle DEC as what? An isosceles triangle. Which means if they form equal angles here, then it means that on the board too, here we have what? Equal angles here. So if I have A here, I'm supposed to have what? A here. Good. Now, this particular triangle, because this line is equal to this line, then it will have a line of symmetry, because if we should divide this way, we can fold this half exactly onto this particular half. And so isosceles triangles, they have one line of what? Symmetry. This is a section A question. One line of what? Symmetry. That is isosceles triangle. Let's move on to the next type of triangle. We have the equilateral or equilateral. Lateral triangle. Equal sides. So in equilateral triangle, we have all the three sides being what? Equal. Bear in mind, when we were treating isosceles, we gave the arc to only two lines, meaning the two lines were the only equal angles. Now, in equilateral triangle, since we have the arc on all the three, it means all the three lines are equal. Don't get it wrong. If I should have double arcs here, it means this line is not equal to this line. But if I should have double line here and double arcs here, then it means all the three sides are equal. Now, to the properties of equilateral triangle. Now, all its interior angles are equal. So all lines are equal. First one, two. All its interior angles are also what? Equal. And that is, each interior angle is equal to 60 degrees, because we are saying that sum of interior angles should be equal to 180. So if all these three should be 180 and they are equal, then 180 divided by 3 will give us what? 60 degrees. So we will have what? 60 degrees here, 60 and then what? 60. So each interior angle of what? An equilateral triangle is what? 60 degrees. And now, let's back to the question. How many lines of symmetry do we have in there? You can pause the video and answer it yourself before you continue. So now, let's see the number of lines of symmetry this particular diagram have on the board. So, since this line is equal to this line, we have our first line of symmetry in here. So we should divide it this way. This half can be folded exactly onto this half. And then also, once this line is also equal to this line, we can also divide it exactly this way. And so, this half can be folded exactly onto this particular half. And the last one, once this particular line is equal to this particular line, we can also divide it this way. And then this half can be folded exactly onto this one. So, an equilateral triangle has three lines of symmetry. Three lines of symmetry. Let's move on to the last particular type of triangle. Then we get into the question. So, we have the right-angled triangle. Now, when we were treating under type of angles, a right angle is an angle equal to 90 degrees. And so, a right angle triangle, we said triangle is an enclosed plane figure bounded with three sides. So, a right angle triangle means what? One of its interior angle is equal to 90 degrees. Good. So, once we have our 90 degrees here, then it's made this triangle a right angled triangle. And don't get it wrong. It is possible we will have isosceles right angle triangle because these other two lines may be equal in length. So once these other two lines are equal in length, then we could have what? An isosceles right angle triangle. You could also have something like, what is an acute triangle? Acute triangle simply means that the interior angle of the triangle is less than 90 degrees. Or the interior angle of the triangle are less than 90 degrees. So I may have something like 58 here, I may have 62 here, and I may have 60 somewhere else. So when we add everything, it's equal to 180. But each interior angle is less than 90 degrees. And also, when you talk of obtuse triangle, it means that one of its interior angle is more than 90 degrees but less than 180. Then it is called an obtuse triangle. Thank you. Now let's get into the question and then we see how best we could solve it. Now, we have line CB, so line CD equal to line DE as said earlier. So it means this angle is equal to this angle. Now, in order for us to solve for x, as you can see on the board, we need the help of certain angles and we need the help of this angle as well as, if possible, we also need the help of this angle. But we can do without the help of this angle. We can do with the help of only this one. And also, we can also do with the help of this as well. So, this angle here, you could see clearly that it is corresponding to this particular angle here. Let's bring that particular portion out. We have a line AJ. You could see line AJ. We have two arrows here, so it means it's parallel to the two arrows on this particular line. So line CE is equal to line A. They are parallel to line AJ. Good. And so we have our AJ and then we have our CE. So they have two arrows on them this way. So in that case, line AC this way becomes the transversal line. Good. And we are saying that whenever a line crosses through parallel lines, the angle that formed beneath is corresponding to the angle that's formed beneath the other parallel line. So this is corresponding to this line. So this angle is corresponding to this angle. So you could see in this particular diagram, at our angle C, you could see here, which is the A here. Let's put a variable here, let's say V. Is corresponding to angle V here. Good. Angle A is corresponding to angle V here because it is beneath this parallel line and it's also beneath, the V is also beneath this parallel line. So they are corresponding angles. So let's solve for A and then we proceed from that particular end. With A, we said the sum of interior angle of a triangle should be 180. And so I have my A plus my A plus my 70 degrees here should be equal to 180. Good, because the sum of interior angle of a triangle is 180. We can add or subtract like terms. And so A plus A will be 2A plus 70 equals to 180. We transpose this one here. We have 2A equals 180 less 70. We have our 2A equals 110. And to find, in order to solve for A or find A, we divide both sides by 2. Then our A10 was 55 degrees here. Good. So that is 2 into 110 is what? 55. Good. So we have 2 into 110, we have 55, and then 2 also cancels 2 out. So the final answer 10, A is equal to 55 degrees. Good. Now, we also said V is corresponding to A because these two lines are parallel. That is AG and CE are parallel lines. So the angle beneath the parallel line is also equal to the angle beneath the other parallel line. And they are corresponding. And so V here is equal to A. V is equal to A. But we have our A to be 55. So V is equal to 55 degrees. V is equal to 55 degrees. Now, to our second property of triangle, we said an exterior angle. You could see, this is the exterior angle with a blue arc. This particular angle. So we said this is an exterior angle of triangle AGB. 3 sides enclosed. So this particular exterior angle is equal to these two opposite interior angle. That is the 40 and the V of that same triangle. Doing our second property of triangle. Good. So you could have X here. So we have X here should be equal to V plus 40. V plus 40. And so X is equal to V is 55 degrees plus 40 here. So x is equal to 95 degrees. Gently on the board, 95 degrees. Good. Now that we have the value for x, now this is another one arrow on this particular line. Line AD has one arrow and line FE has also one arrow. It means this line is parallel to this particular line. Good. And so we are saying whenever angles are within the parallel lines and they are at one side of the transversal line, good, then they become co-interior angles. And so V here plus y, it's rather x here plus y should give us 180. Why? Because we are saying that co-interior angles add up to 180. Our x is 95 degrees and then plus our y should be equal to 180. We have our y equal, we are grouping items, so let's join this one here. 180 less 95 degrees, then y times 85 degrees. And this brings us to the end of the solution for this particular question. In a different way too, we can add this and this equal to 180, solve for this particular angle, and then we have straight line here or supplementary angles at this particular point here, and then we will say u plus x is equal to 180 because straight line angles add up to 180. Thank you so much for your time. And in our next video, we will be treating quadrilaterals. We will go into quadrilaterals and solve another one past question relating to quadrilateral. Thank you.